Welcome to Spring LIB.
For this situation, we're considering light with a wavelength lambda of 450 nanometers or 450 times 10 to the minus 9 meters, incident on a single slit with a width d of 1.0 millimeters or 0.001 meters, and the distance the screen is away in which the diffraction pattern is being projected is L, and it's 5 meters. We're asked to find the width of the central maximum in units of centimeters. Okay, so the central maximum is surrounded by the first minimum. So the condition for the first minima here is what we're going to use to begin with, and this is d times the sine of the angle, which we need to find that angle in order to find the distance, is equal to m times lambda. But since we're considering the first diffraction pattern, m here is equal to 1. In other words, theta is equal to the inverse sine, so we're solving for theta, the angle, the inverse sine of lambda over d. So plug those values into this expression, and we find the angle here is about 0.026 degrees. Okay. Well, using a trigonometric identity, the tangent of that angle here, theta, and let's actually write it up a little bit higher so we have more room. The tangent of the angle theta is equal to the distance between the the width of the central minima, x, that we're trying to find, just to one of the central minima though, not to both, divided by the length L. So I can kind of draw that out over here in green. So essentially what we're finding here is we have this length L, we have this x, and here is theta. So that's where the tangent of that comes from. Okay, so now we can go ahead and rearrange this to solve for x, because we want to know x. This will be the distance from the center to one of the central maxima, but we want the total width, so we're going to have to double this x value to find that. But first we have to find x. We find that x is equal to the tangent of theta times L, right? Plugging those values into this expression, we find that x is equal to 0.00225 meters, or 0.225 centimeters. Well, the actual width here that we're trying to find, the width of the central maxima, is 2 times that. So we'll say W here is 2x, or in other words, 0.45 centimeters. Since we were asked to put it in centimeters, I put it in centimeters. And we can go ahead and box that in as our solution to the question.